Hi everyone. Uh, Today we are going to discuss very interesting topic about this quark model. The quark model it is proposed year 1964. This model was proposed by the Gilman and Swag. Independently, they proposed this model. The two famous scientists. One is Gilman and Swag. Okay. So according to the Gilman, all hadrons are in fact composed of even more elementary constructs, so which Gilman called quark. The quarks uh, come in three different flavors. I mean, three different types. One is up, down star. Okay, up, down, and strange. And this is up, and this is down. Okay, this is strange. Strange. So these are formed a triangular pattern. Triangle wave pattern. Okay. So let us try to draw the graph. Oh, just like this pattern. Okay. So this is a triangle way. Here the Gilman arranged like this. This down and this is down. So this one is up. This one is strange. Okay. This one is strange. So if you try to draw the graph between the strangeness number and isospin third component, we already discussed previous class eightfold wave arrangement of quarks. So if you don't know how to draw the graph between the isospin versus strangeness number or hypercharge, please go and watch that eightfold way quark model. Okay, initially we discussed that thing. So by considering that only, I'm drawing this. So this is the graph between the strangeness number and isospin of third component. So this portion is this portion, entire this portion. Okay? Strangeness number s equal to 0, and this portion is the this portion of this s also. Okay, this portion is there, right? It is better to write here. Okay. Okay. S equal to s equal to -1. So the horizontal or the same group, uh, and the diagonal, this diagonal is there right here. uh, in case if I draw like this pattern, this is the diagonal. Okay, here also is diagonal. Okay, so whatever this diagonal is, diagonal, these are the same charge, which means uh, range and down, whatever elementary particles come here, the same charge. Okay, and this q equal to minus 1 divided by 3. So up charge is q equal to 2 divided by 3. So this is the basic quark model. Quark. So in the U, it is stand up quark carries a charge 2 divided by 3 and a strangeness of 0. The down quark carries charge minus 1 divided by 3 and strangeness number 0. So the quark has yes, this one, the strangeness number is equal to minus 1. That is the strange of the quark one. So that is exactly placed here as equal to the charge of this range is minus 1 divided by 3. So in case uh, the corresponding up down strange, corresponding of this up down strange, their anti-quarks also there, the quarks like this. So if you put any bar over this letter, then we can call that the anti-quark. Anti-quarks, these are the quarks, these are the anti-quarks. So if you try to arrange the graph, a similar graph between the things, see here. Okay, so this one is, this portion is, this is the ES bar. So this is down bar, this is up bar. Okay, so anti-quarks. These are the anti-quarks. So here the strangeness number of this portion s equal to 1. The strangeness number of this portion, anti-quarks of down, anti-quarks of up. So the strangeness number s equal to 0. So the quark model asserts that two rules. One is the every baryon is composed of 3 quarks, and second one is every meson is composed of a quarks and anti-quarks. So it is better to write these two rules. The quark model asserts that one is every baryon is composed of three quarks. Hmm. or in case anti-variants are there. Here the variance is composed of three quarks. Okay, only up, down, then three quarks. We don't know what these numbers, either proton, neutron. We'll discuss later. Okay, three quarks, normal quarks. Okay, so if you want to try to find the anti-variance, you need to use the uh, three anti-quarks. So anti-variance is composed of three quarks. Okay, three anti-quarks. The second rule is the every meson is composed of a quark and an antiquark. Every meson is composed of a quark, okay, a quark and an antiquark. So with these two rules, it is a matter of elementary particles to construct the baryon and meson's octet values. So all we need to do is a combination of the three quarks or the combination of three antiquarks and add up their charges and ranges number. So suppose if I take this for example, uh, here we will discuss the charge and all these things. Sorry, here I forgot to write the charges value. The antivariant of charge, we know horizontal thing. This one charge is q equal to minus 2 divided by 3. This is q equal to 1 divided by 3. The charge is the horizontal thing. Okay, horizontal, like this. So these are the basic fundamental things. If you try to remember these fundamentals, what is the charge of down, what is the charge of the up, what is the strangeness number of the uh, down quark, or strange of a strangeness number, so then it is easy to find the elementary particles, quarks. So first here I'm going to discuss the baryons, which means the baryons spin 3 divided by 2 particles. Okay, so we have two different type of baryons spin 1 divided by 12 baryons spin uh, uh, 3 divided by 2 baryons. Sir, here I'm going to discuss the spin 3 divided by 2 baryons. Spin 3 divided by 2 baryons. Okay. So first I'm going to discuss here, in case add if I add uh, 3 up quarks. So what is the charge of this up quark? Charge is 2 divided by 3, as is strange number is 0, right? So 2 divided by 3, 2 divided by 3, 2 divided by 3. So therefore this is charge, this is strangeness number. So these are the baryons. Okay, baryon. So this is the first step. The charge of this state is u up 2 divided by 3, 2 divided by 2 divided by 3. So you get 2, right? Strangeness number 0. Then they are find this value. So charge 2, strangeness number 0 particle. So what is that particle? Delta plus double plus. So this is, don't forget this. This is total charge, 2 divided by the total charge, right? This one. So 2 divided by 3, 2 divided by 3, 2 divided by, then you can get this charge. And the strangeness number 0. This is the delta particles, delta plus plus particles. Okay, please try to remember this. And next important thing is U U D, up up down. What is the down charge? What is a down charge? Minus 1 divided by 3. So therefore you can get here, this is 2 divided by 3, 2 divided by 3 minus 1 divided by 3, right? So charge we can get here the 1. Strangeness number is 0. So charge is 0, charge 1, strangeness number 0 is uh, delta plus particle. So like that you can find the all the variance number. Okay, so here I'm going to write the remaining things. In case if you take U D D uh, charge 0, you can get ranges number 0 is particle delta 0. Next is down down down, minus 1 0 delta minus. These are all variants, right? Okay. Next up strange. So charge 1, strange is number minus 1. So this is the test particle. The next important one is down down strange. You take this type of combination, then you can get here the minus 1 minus 1. Sorry, one more thing is the just quite. So here I miss sequence. Okay, no problem. So up down strange 0 minus 1. This is sigma particle, sigma star minus. The next down down strange minus 1 minus 1. This is 0 sigma star minus. Next USS 0 minus 2 cos I particle, cos ka d particle, cos KSI particle, right? I particles. DSS minus 1 minus 2. This is also the minus 2 charge, also minus, and this is minus particle. Strange, all the strange particles. So these are the baryons, all the baryons. In case if you try to arrange this structure uh, mesons, so don't forget these rules. Baryons is composed of three quarks. Three quarks. Mesons is composed of quark and anti-quark. Not three quarks, only two quarks. One is out of two, one is quark, another one is anti-quark. It is not necessary one is quark, another one is anti-quark. In case if you try to observe the particle k plus, if you combine the up and strange, then you can get k plus particles, kaons. Okay, so it is not necessary one is quark, another one is either. If you want to find the mesons, we have two quarks. One is quark, another one is anti-quarks. It is not necessary both are. I mean, one is quark, another one is anti-quarks. Some cases, you try to find the K plus particle, K plus Meson particle. If you add up and strange, then you can get K plus Meson. So in case if you want to pi minus ions down and up antiquark, so it is better to write the structure also in mesons, mesons. So mesons q bar, right? Two quarks. Okay. So similar thing here. I'm going to use the charge range number meson particle. Meson. Okay. Add up and anti-quarks of them. So what you get here? Zero, right? Charge. Range number also zero. This is the I zero meson. So what is the charge? Up quark charge. See, up. What is the up and this is minus 2 divided by 3 anti-quarks. This is 2 divided by 3. So total charge, it yields to the uh, 0 and range is number 0. Then we can get meson here. The pi 0 is the quark structure. This is the quark. And U D bar. This is anti-quark 1. So remaining thing you can write. No problem. D U bar minus 1 0 pi minus D bar 0 0 0 0. This is net, which is why I am talking. If you take the up quark under strange, then you can get charge 1 and the strange is number 1. This is the K plus mesons, K mesons, right? K plus. So which is why I'm called. It's not necessary one is a quark, another one is anti-quark. So if you want to find mesons, we need 2 quarks only. If you want to find baryons, we need 3 quarks only. This is the rule. Okay. These are the baryons, these are the mesons. DS bar. So 0, 1 and K naught and S U bar minus 1 minus 1 K minus. So these are the fundamentals of quarks. So in examination, they are asking the directly question. So what is a quark of the proton, neutron, K mesons, and what's the baryon? For example, if they are giving this number, this is the for example, if you take this value, this baryon, okay, sigma baryon, sigma minus, okay, they try to ask what is the quark state. This is the quark state, okay. So for simplification, how to remember these quarks in terms of eightfold way is very easy to find these quarks in terms of eightfold way. So here I'm going to discuss the first thing is the mesons in eightfold. Okay, mesons. So we already discussed how these particles are arranged with uh, hypercharge versus I mean hypercharge versus I3 component and this or Arrhenius number component versus the I3 components. Isospin third component graph. So if you don't know, I'll show you one more time that thing. Just wait here. Here is the so this is the graph, main graph. So initially I discussed these things, this graph, see eightfold way. Here, like this, you need to arrange the graph between the hypercharge versus I3 component Or you can take here the strangest number S also. Then we try to use the conservation laws. You can find I3 variant number, lepton number, charge, hypercharge, strangest number, right? Then you can try to arrange this graph according to the conservation rules and regulations. Then you can get this type of structures. So this is the fundamental information. By using this graph only, they are arranging uh, the eightfold way, uh, triangle. This thing, okay, they are not blindly taking this hexagonal or triangle. It's not just a geometrical representation. Like a periodic table, Mendeleev's periodic table is there. So this is the elementary particles periodic table, how the particles are arranged. It is the Mendeleev periodic table of elementary particles. So for quickly remember these things, for that I'm going to arrange these things to eightfold way. So that is far better than understand anything. So in case mesons, mesons, uh, if I take this, for example, this is the eightfold way, eightfold way. Uh, so this is the K naught. This is K plus. So this is I minus. This is in center, maybe at the center. Two particles are there. That's the eightfold way. Okay. Here is the I plus. Here is the K naught minus. So here the horizontal. I mean this horizontal on the uh, same group is diagonal. Diagonal is there, right? Yes, this is diagonal. These are the same charge. And here also, these are the same charge. This diagonal is the same charge. And this diagonal the same charges. Now you can arrange the what is the quark structure. Uh, so this is D S bar, right? This is U S bar. This is U D bar. And this one U U bar, D D bar, S D bar. And this one is S U bar. And this one is U bar D. So how we can remember these values in quickly? See this, the opposite, write the opposite quarks. Okay. So for example, here D is there. Okay. Now here I'm taking the opposite quarks just. Okay. Up, down, down, up. So this is the simple trick. See the opposite side. Just write the anti-quarks. So this is the shortcut way to remember this sounds easy. Okay, like that you can arrange uh, so it is better to spin. I'm going to arrange the spin 1 by 2 variants. So because many examination point of like gate net just they're asking structure. What are the spin 1 by 2 variants? Proton, neutron, this is one category, sigma plus lambda, this lambda, this is the another group, this quasi group. Okay. These are the particles of spin 1 by 2 variants. So suppose here I'm going to arrange this hexagonal structure. Hexagonal structure. For that, I'm going to draw the graph. Okay. Okay, it is better compared to previous. Now I'm arranging. This is N. So this is P. So this is sigma plus. This is at the center. These two particles and sigma minus. This is quasi particle minus. This is 0. So here also the same rule. The horizontals are the same group. We know this one, right? See here the horizontals are the same group and the diagonal. So this diagonal. This is the diagonal of this group, right? Diagonal of the same chart. This is the diagonal. Diagonal. This is the same chart. This is the diagonal. This is the diagonal. Now you can arrange this quark now. So what is a neutron? D D went down, right? Or U D. So check this U and the strangest number, then you can find this proton and neutron. Okay, and this is U yes. So this is S U. So this is S D. So this is D yes. So here also you see up down strange. So these are the quarks. Here I'm going to uh, discuss one or two problems. Uh, Maybe these are the gate problems. Where it is there. Okay. Yeah. In 2009 gate, they ask one question. In the quark model, which of the following represented the proton? So they are giving the options like this. Option A, U, D, D. Option B, they are asking proton, quark model. Okay. What is the proton quark model? Quark model. Okay. Quark model. They are asking U, D. C equal to U, D bar. So remember one thing. In examination point of view, they are giving four options, right? By seeing these options, we already know. So these protons are baryons. Observe here is option C and option D. These are quark antiquarks. Mesons, right? These are the mesons quarks. So these two options are not correct. Here we are going to spend some time to find the answers. This is the best way to find the correct answer in CSIR net JEST examination. So for that, you need to understand the fundamental how these quarks are arranged, geometrical manner, eightfold way, triangle way. So then you can easily remember this thing. Okay. So this is here is the type U D D, the uh, proton quark model. So this is the correct answer. So many questions are there. 2018, sorry, 2008, 2008. This is 2009. I think gate question. 2008 also they are asking one more quark model. What is the quark model of? These are all one or two more questions on gate and net just examination point of view. This is a quark model of K plus Meson. We already discussed. They are giving some options. They are giving some options. See here. A U U D B C C bar. and C C U S bar D S U bar K plus Meson K plus Meson. So by observing these options, I'm going to remove this thing because this is Barian's quark model, right? So I need to find answer uh, B, C, D. Okay. So K plus Meson. What is the K plus Meson? Here already discussed, right? K plus C. K plus Meson. U S bar. U S bar. Option. This is the correct answer. This is the correct answer. So like that, they're asking questions in GateNet examinations.